Hello learners, and welcome to today's section of the online teaching and learning. My name is Day Leonard and I will be your maths tutor for today. Today the topic we are looking at is the Pythagorean Theorem. It sounds familiar, right? It's a very simple theorem we are about to delve into today. Pythagoras, a Greek philosopher and mathematician, is credited with the discovery of the Pythagorean Theorem. He realized that for every right-angled triangle, there is a proven relationship between its magnitudes. When I say magnitude, I mean the distance or the length around the right-angled triangle. This is to say that the Pythagorean theorem is used if and only if the triangle is right-angled. What then is a right-angled triangle? A right-angled triangle is a triangle which has one of its interior angles to be exactly 90 degrees. Now, the Pythagorean theorem states that for every right-angled triangle, the square of the longest side is equal to the sum of the squares of the other two sides. How then do we determine the longest side of a right-angled triangle? The longest side of a right-angled triangle is the side opposite to the 90 degrees angle. Looking at the diagram on our screen, the 90 degrees angle is at B and it's opposite the line AC. So line AC is our longest side. So then the Pythagorean theorem is stated as AC squared is equal to AB squared plus BC squared. Again, AC squared is equal to AB squared plus BC squared. Let's consider these three diagrams. You are to identify the longest side and state the Pythagorean theorem from them. You have 30 seconds for each diagram. So in all, you have 1 minute and 30 seconds. Your time starts now. I believe by now your answers are ready. For the black triangle, the longest side is XZ. The theorem is stated as XZ is equal to X. Let me take it again. The theorem is stated as XZ squared is equal to XY squared plus YZ squared. For the green triangle, the longest side is QR. The Pythagorean theorem is stated as QR squared is equal to PR squared plus PQ squared. Last but not the least is the blue triangle. The longest side is KL. And the Pythagorean theorem for that is KL squared is equal to LM squared plus KM squared. What was your score? I believe you had all correct. Now let's move to solving some problems involving the Pythagorean theorem. On our screens is a right-angled triangle labeled ABC. We are being asked to find the magnitude of the line AC. Line AB has been given as 3 centimeters and BC given as 4 centimeters. From this diagram, we can state the Pythagorean theorem as AC squared is equal to AB squared plus BC squared. Since we know AB and BC, we can make the substitutions. So AB is 3 and BC is 4. Mind you, they are squared. The square of 3 gives us 9, and the square of 4 gives us 16. Summing them, we have 25. Therefore, AC squared is equal to 25. We are being asked to calculate the length or the magnitude of AC, not AC squared. So to take off the square, we must introduce the square root. And in mathematics, whatever we do to the left-hand side, we do the same to the right-hand side. So we introduce the square root to both sides. So we have the square root of AC squared being equal to 25 squared. The square root of 25 gives us plus or minus 5. But because we are dealing with distance or magnitude, and magnitude cannot be negative, we are going to consider only the positive numbers. So AC will be equal to 5 centimeters. Let's try another example. So example 2. We have another right-angled triangle, which is PQR. With this triangle, the longest side has been given. That is PQ. So PQ is 10 centimeters. RQ has been given as 6 centimeters. And we have been asked to find the magnitude of the line PR. Stating the Pythagorean theorem from this right-angled triangle, we are going to have PQ squared is equal to PR squared plus RQ squared. As we can see, PQ is known and is 10 centimeters. RQ is also known and that is 6 centimeters. So we make the substitution rightly. 10 squared gives us 100 and 6 squared gives us 36. So we have 100 being equal to PR squared plus 36. At this moment, because we are looking for or we are calculating for PR, we would need to group like terms. So we are transposing 36 to the left-hand side. It is positive, so when it comes to the left-hand side, it becomes negative. So we have 100 minus 36 being equal to PR squared. The difference gives us 64. So we have 64 being equal to PR squared. Again, because we are looking for PR, or we are calculating for PR and not PR squared, we take the square root of both sides. So we have the square root of 64 being equal to the square root of PR squared. Square root of 64 gives us 8. And the square root takes off the square sign. Therefore, PR is equal to 8 centimeters. Very simple, isn't it? On your screens are two different diagrams, two different questions, question 1 and question 2. You are going to try these questions on your own. Afterwards, I will present the ideal solution. You can compare to yours afterwards. Question 1, you are being asked to find the magnitude of RT. Question 2, you are being asked to find the magnitude of DM. You have a minute for each question, and your time starts now. I believe by now your solutions are ready. So let's present the ideal solution while you cross-check with yours. Question 1. The Pythagorean theorem is stated from the diagram as RT squared is equal to RS squared plus ST squared. From the diagram, the magnitude of RS was given as 5, and that of ST was given as 12. So we make the substitutions rightly. 5 squared gives us 25, and 12 squared gives us 144. Putting them together, we have 169. Therefore, RT squared is equal to 169. To take off the square sign from the RT, we introduce the square root sign to both sides. Therefore, RT is 13 centimeters. Always remember to bring your unit of measurement. Question number 2. The Pythagoras theorem from that question will be km squared is equal to dm squared plus dk squared. From the diagram, km was given as 25 and dk was given as 24. So we make the substitutions rightly. Don't also forget that they are squared, so you need to square them. The square of 25 is 625, and the square of 24 is 576. We would need to transpose 576 so we can find our dm. So transposing to the other side, we have 625 minus 576, which gives us 49. So we take the square root of both sides so we can find our dm. Squaring both sides, we have the square root of 49 is equal to the square root of dm squared. So our square root takes off the square sign, and we have our dm to be equal to 7 centimeters. What was your score? I believe you had everything right. Using the Pythagoras theorem to determine if a given triangle is right triangle. Pythagoras theorem can be used to determine whether a triangle has a right angle. The triangle contains a right angle if the sum of the squares of the two shorter sides equals the square of the hypotenuse. I take that again. The triangle contains a right angle. And as I explained earlier, a right angle is an angle that is exactly 90 degrees. So the triangle contains a right angle if the sum of the squares of the shorter sides equal the square of the hypotenuse. And the hypotenuse here is the longest side. Let's consider this example. Thus, the triangle ABC contains a right angle, as we read earlier. For the triangle to contain a right angle, the square of the longest side, which is the hypotenuse, should be equal to the sum of the square of the other two sides. So our ideal solution, step 1, we find the square of the line AB. AB, the magnitude was given as 5. The square of it is 25. Then we find the square of the line AC. The length AC was given as 6. The square of it is 36. So the third step, putting the two together, 25 plus 36, it gives us 61. This gives us the sum of the squares of the two shorter sides. Now let's look for the side that is the longest. That is BC. The magnitude is 8. So 8 squared gives us 64. The sum of the two shorter sides gave us 61. And the square of the hypotenuse, that's the longest side, gave us 64. Clearly, 61 is not equal to 64. Therefore, this triangle does not contain a right angle. I believe the understanding is very clear. On your screen, we have 5 different triples. You are to determine whether the following triples have right angles. Obviously, for each triple, the highest figure represents the hypotenuse. Some of the triples would have right angles, others would not have. So per what we've just done, use the same knowledge to determine whether the following triples have right angles. Copy them and start now. Let's move to the application of Pythagoras theorem. The Pythagoras theorem is being used in real-life situations, and it is used to solve real-life problems. The theorem has numerous real-life applications in various fields. Some of these fields include construction and architecture, navigation and survey, physics and engineering, computer graphics, GPS and mapping, and so many others. You can find them out later. Now let's use the Pythagoras theorem to solve some real-life problems. The screen of a rectangular television has its diagonal to be 41 inches. If it has a height of 9 inches, how wide is the television? Let's take the question again. The screen of a rectangular television has its diagonal to be 40 inches. If it has a height of 9 inches, how wide is the television? Let's look at our ideal solution. From the question, the screen of the television is a rectangle. So as you see from your screens, a rectangle is depicted. One of the properties of a rectangle is that all 4 interior angles measure 90 degrees each. The diagonal stretches from the top corner to the opposite down corner, as depicted in the diagram on your screens. According to the question, the diagonal is 41 inches and the height of the television is 9 inches. We are being asked to calculate how wide the television is. And because we don't know that, we have represented that by the variable x. Clearly, we can use the Pythagoras theorem to find how wide the television is. From this diagram, the theorem reads 41 squared is equal to x squared plus 9 squared. The square of 41 gives us 1,681. And that will be equal to x squared plus the square of 9, which gives us 81. So to find our x, we need to first transpose. So 81 moves to the left-hand side and it becomes negative. So the difference now gives us 1,600, which is equal to x squared. To find x, we need to square both sides. The square root of 1600 is 40. And on the right-hand side, the square root takes up the square sign, so we have x. Therefore, x is equal to 40. Mind you, this is a word problem. So at the end, you narrate your answer nicely. So therefore, the television is 40 inches wide. I believe this is very understandable. Let's move to the second example. So example 2. A ladder leans against a vertical wall of height 15 meters. If the base of the wall and the foot of the ladder are 10 meters apart, find to the nearest meter the length of the ladder. Let's look at our ideal solution for this question. According to the question, the wall is 15 meters high, and the foot of the ladder and the base of the wall are 10 meters apart. The question saying that the wall is a vertical wall indicates that it makes an angle of 90 degrees with the ground. If a ladder leans against that wall, then obviously a right-angled triangle is created, as depicted on your screens. From the question, we are to find the length of the ladder. And since we don't know, we are representing that side by the variable a. So the Pythagorean theorem from this right-angled triangle reads a squared is equal to 15 squared plus 10 squared. 15 squared gives us 225. 10 squared gives us 100. Putting them together, we have 325. For us to be able to find a, we must square both sides. So we have the square root of a squared being equal to the square root of 325. Therefore, our a is equal to 18.0277. Our question asks us to leave our final answer in the nearest meter, and that gives us 18 meters. Therefore, the ladder is 18 meters long. I believe this is very understandable. Let's try another example. Example 3. A rectangular garden has a diagonal path that measures 20 meters. If the length of the garden is 15 meters, calculate, correct to 2 decimal places, the width of the garden. So let's consider the ideal solution for this question. According to the question, the diagonal of the rectangular garden is 20 meters, as depicted in the diagram you see on your screens. And from the question as well, the length of the garden is 15 meters. The side we don't know is the width, and we have represented that by the variable u. So stating the Pythagorean theorem from this diagram, we are going to have 20 squared is equal to u squared plus 15 squared. 20 squared gives us 400, and that will be equal to u squared plus the square of 15, which gives us 225. Clearly, we need to transpose so we can find our u. So we transpose 225 to the left-hand side. So we have 400 minus 225 being equal to u squared. The difference gives us 175. So to find u, we must take the square root of both sides. So we have the square root of 175 being equal to the square root of u squared. The square root of 175 gives us 13.28. Let me take that again. The square root of 175 gives us 13.228. So u therefore is equal to 13.23, since we have been asked to leave our answer in 2 decimal places. Therefore, the width of the garden is 13.23 meters. On your screen is a try work for you. So let's read together. A square with sides 25 centimeters is to be folded such that 2 triangles are formed from it. Find the magnitude of the longest side formed from the triangle, correct to the nearest centimeter. You have just a minute and a half to solve this question. Your time starts now. I believe by now you are done. So let's see our ideal solution. One of the properties of a square is that all sides are equal. So we have 25 being the length and 25 also being the width. According to the question, we are to fold the square in such a manner that we can get 2 triangles. And obviously, we must fold them on the diagonal side. So finding the length of the longest side will mean we are finding the hypotenuse, or the side that is opposite our 90 degrees angle. So from the diagram, we have represented that by the variable w. Stating the Pythagorean theorem, we have w squared is equal to 25 squared plus 25 squared. 25 squared gives us 625. Doubling it, we are going to have 1,250. And again, we must take the square root of both sides to find our w. So our w is going to be 35.355. So the nearest meter is going to be 35 centimeters. I believe you had this right. These are examples of some Pythagoras triples. By Pythagoras triples, I mean that there are some numbers that move together when it comes to the Pythagoras theorem. So when the 2 shorter sides are 4 and 3, the longer side will be 5. Considering the second point, when the 2 shorter sides are 5 and 12, the longer side will be 13, and so on and so forth. These are not the only Pythagoras triples we have. There are a lot of them, and I expect you to find them out. We are coming to the end of the lesson, and I would like to leave you with some examples to work on your own. So we have on your screen assignment 1, 2 right-angled triangles in one diagram. You are supposed to find the magnitude of the line AC and AD. Draw them quickly and work them at your own pace and in your own time. Assignment 2 and 3 are real-life applications. So let's read them together. A ladder 16 meters long leans against a wall that is half the length of the ladder. How far is the base of the wall away from the foot of the ladder? Leave your answer to the nearest meter. Assignment 3. A ship sails 15 kilometers east and then 20 kilometers north. What is the shortest distance? By that we mean a straight line back to the starting point. Per the knowledge we have gathered so far, I believe these questions will be very easy for you to tackle. We have come to the end of the lesson, and I believe it has been an exciting one. I expect you to practice day in, day out. My name is Mr. Day Leonard. We'll meet some other time. Thank you.